Welcome to this project walkthrough, where we'll build an end-to-end data engineering pipeline for analyzing global malaria data. The workflow starts with raw files in Azure Blob storage, flows through Azure Data Factory for cleaning, standardization, and aggregation, and lands in silver and gold layers for analytics and visualization. Step 1. Raw data in Blob storage. Our source is Azure Blob storage. We have three data sets: malaria cases, socioeconomic indicators, and climate data, stored in the bronze layer. Here are the three raw data. It already we have made. Step 2. Linked services and datasets. In Azure Data Factory, we configure linked services to connect to Blob and Azure SQL database. Then we create datasets for each raw source file, cases, GDP_data, and climate, showing datasets DS Blob cases. This dataset contains the number of malaria cases and deaths for each country and year. This dataset includes environmental factors such as rainfall and average temperature, which are critical to malaria transmission modeling. This dataset contains socioeconomic data like GDP and population, important indicators that influence malaria trends. We have three input datasets from Blob storage, one for cases, one for socioeconomic factors, and one for climate data. All these will be combined and processed in our mapping data flow to produce clean, high-quality silver and gold datasets stored in data lake. Now let's move to our first data flow, where we clean and standardize raw malaria, GDP, and climate data into a single silver dataset. Here's how the transformations work step by step. Sources are: we start with three sources: malaria cases, GDP data, and climate data. These are imported directly from our bronze layer in Blob storage. Check the data preview. See the process carefully. The first join performs a full outer join between cases and GDP datasets, using country_code and year as keys. This ensures we capture all rows, even if data is missing on one side. Check the data preview. Join 2. Next, we join the output with the climate dataset, again on country_code and year. This unifies all three datasets into one stream. Check the data preview. Now select. After joining, we standardize the schema. We rename columns to consistent names like cases, deaths, GDP, population, rainfall, and temperature. This makes downstream processing easier. Check the data preview. Now make filter. We filter out invalid data. For example, we remove rows where country code or year is null, where the year is before 1990, or where cases and deaths are negative. Check the data preview. Create aggregate. Next, we aggregate the data at the country year level. We sum up cases and deaths, calculate average rainfall and temperature, and keep the latest GDP and population values. Check the data preview. Now derived column. We then add calculated metrics. For example, incidence is cases per 1,000 population and mortality is deaths per 1,000 population. These derived measures will be key for analysis. Check the data preview. Now sync. Finally, the cleaned and enriched dataset is written to the silver zone in ADLS, partitioned by country and year. This completes our first stage of the pipeline. Check the data preview. So, in this step we unified raw malaria, GDP, and climate data, applied cleaning rules, performed aggregations, and created new health metrics. This silver dataset is now ready for downstream analytics. In this video, we showcased how to build a scalable ADF pipeline for malaria data analytics from raw blob files. This enables researchers and health agencies to track malaria trends with actionable insights. Thanks for learning with us. Please share your comments.